Hello everybody, in this video we're going to talk about the difference between an even and an odd function. So let's look at some definitions. For both of these, we're going to take our original function and we're going to make the input or the x value opposite, just in our original function, just the x value. Once we do that, we're going to simplify the equation and we're going to see what we're left with. If we get exactly what we started with, okay, so f of x is equal to 4x and we end up with 4x, we would consider that an even function. And once we graph it, its graph should be symmetric about the y-axis, which means we could fold it over the y-axis and it would map on top of itself. On the other hand, if we make x opposite, we simplify and we end up with the opposite of the function that we started with, so negative f of x, then that is considered an odd function and it's symmetric about the origin, which means if we folded the graph over the origin, it would map on top of each other, okay? So functions can be even, they can be odd, or they can be neither. So we're gonna look at 3 examples and we're gonna see one of each. So the first one is a linear function, f of x equals 4x. So I'm gonna graph these 3 really quickly, but I have videos on how to graph each of these in more detail. So I'll be posting some cards in the top right-hand corner as we get to each of these examples. So here's the first one, how to graph a linear function. So we're gonna go ahead and graph this. Let's say y-intercept, 1, 2, 3, 4, right 1, 1, 2, 3, 4, and left 1. Okay, so once we graph these, we might already be able to see which part of the graph they're symmetric about, either the origin or the y-axis. Okay, but let's go ahead and make x opposite and see kind of what we're talking about. So we're going to say f of the opposite of x, and instead of 4x, we're going to say 4 times negative x. So once we simplify this, this just equals negative 4x. Okay, so now 4x is what we started with. Negative 4x is the opposite of that. So we started with f of x and we ended up with the opposite of f of x. So we consider this an odd function, which means it's going to be symmetric about the origin. Okay, well here's the origin. So what it means to be symmetric about the origin is if we were to fold this graph or this part over the origin, it would map on top of the part on the bottom, okay, and vice versa. If we took this part and folded it to the top, it would map on top of itself. All right, for number 2, we have a quadratic that's in the form ax squared plus c. So how to graph that is in the top right-hand corner right now. So we're going to graph it really quickly. 1, 2, 3. So this one's going to be a parabola. I'm going to plug in 1 for x. So I get 1 squared is 1, 1 times 2 is 2, and 2 minus 3 would be negative 1. And I'm going to reflect that point over here to get my parabola. Okay. So now we can kind of see that that's symmetric about the y-axis. So let's see if we do in fact get an even function. So let's make x opposite. So 2 times negative x squared minus 3. So negative x is just, or negative x squared is just x. And so now we get the exact same thing that we started with. So we're going to consider this an even function, which is why it is symmetric about the y-axis. Okay, so here's our y-axis. I just made it red. So what that means is if I fold this part over the y-axis, it lines up with the part on the right, and vice versa. If we fold the right over to the left, it would map on top of itself as well. Now the last one. The last one is a quadratic in standard form. So the card in the right-hand corner tells you how to graph that one. So very quickly, I'm going to find the axis of symmetry, which is opposite of b over 2a. So that's going to be at x equals 1. So I'm going to draw my axis of symmetry and make it a dashed line. And now I'm going to plug in 1 for x so I can find the y-coordinate of my vertex so I can plot that point. So this is going to be 1 squared is 1 times 2 is 2 minus 4 plus 4. So this will just equal 2. So that means my vertex is at 1, 2. And this value right here is c, which is my y-intercept. So 1, 2, 3, and 4. And then I can reflect that y-intercept over my axis of symmetry to get my parabola, okay? So now we can see it's not symmetric about the origin, it's not symmetric about the y-axis, so this one should be neither. So let's see what happens when we make x opposite. So let's say 2 times negative x squared minus 4 times negative x plus 4. So this is still 2x squared, but now here we get plus 4x plus 4. So now 2x squared plus 4x plus 4 is not the same as 2x squared minus 4x plus 4, and it's not the opposite, so we consider this one neither. Okay, so that's how to tell if functions are even, odd, or neither.